In the figure below, two circles meet at points P and Q, and diameters PA and PB are drawn. We want to show that line AB goes through point Q. So let's go ahead and start this proof. We're going to let circle T be the unique circle that goes through non-collinear points P, Q, A, right? P, Q, and A. All right. Since PA is a diameter for circle T, this implies that T is an element of PA. That means that T lies on PA, right? Similarly, we're going to let circle R be the unique circle that goes through non-collinear points P, B, and Q. All right. Since PB is a diameter for circle R, this implies that R is an element of PB. All right, so that means that R is going to be placed on PB. Now, we're going to use, we know that, let's go ahead and label this J and label this K. We know that since PA is a diameter, for circle T implies that PJA, this arc, is a semicircle, right? Arc PJA is a semicircle, which, okay, for circle T, which implies that the measure of arc PJA is equal to 180, right? So we know this arc PJA is 180. Similarly, we know that PKB is a semicircle because PB is a diameter. So PB is a diameter for circle R, implies that arc PK, right, PKB is a semicircle for circle R, which implies that the measure of PKB is equal to 180. All right, so now, as you can see, I redrew it here. Now I'm going to draw line PQ. Okay, so there's PQ. Now I know that this angle here is an inscribed angle for circle T, right? So by the inscribed angle theorem, I know the measure of angle PQA is equal to half the measure of arc PJA. But earlier I showed that the measure of arc PJA was 180. So this is equal to half of 180, which is 90. So I know the measure of angle PQA is 90. Similarly, I can see that by the inscribed angle theorem that the measure of angle PQB is equal to half the measure of arc PKB, right? But remember, earlier we showed that measure of arc PKB is 180. So that's half 180, which is 90. Okay, so now we can see that this implies that PQ is perpendicular to AB. So this implies that A, Q, and B are all on the line AB. And then, of course, this implies that AB goes through Q. And that is the proof.